Hello. My name is Andi Febrianto from Faculty of Engineering of Universitas Sanggubuana Bandung. On this occasion, I will review an international journal with the title Carbon Dioxide Monitoring System for Prototype of Building Air Quality Management Using Wireless Sensor Network. This research was made by Novian Habibi, Rindra Viska, Ali Arshad and friends from Faculty of Computer Science, Universitas Indonesia. This presentation is divided into 6 sections. First, introduction, second, literature review, third, research method, fourth, results, fifth, conclusion, and sixth, recommendations. Carbon dioxide is a gas that consists of 3 atoms. These atoms are 2 oxygen atoms and 1 carbon atom. This gas plays an important role in the daily lives of every living thing on the planet. For example, the carbon dioxide is needed by plants to do the process of photosynthesis. The photosynthesis will then release oxygen, which is one of the most important gas for a human being. Using electronic goods could also produce carbon dioxide. Since the Industrial Revolution, humans have been dependent of machineries and electronic goods to conduct their daily activity. The activities that used machineries and electronic goods will emit carbon dioxide. According to a research that was conducted by Samiaji, Indonesia is the largest country that emits carbon dioxide from biomass burning. Too much carbon dioxide that exists in the ecosystem will affect the balance of the ecosystem. Greenhouse gas is one of the major causes of global warming. Greenhouse gas is comprised of several components. The main component of greenhouse gas is carbon dioxide. The high composition of carbon dioxide inside the greenhouse gas means that the concentration of carbon dioxide will indirectly affect the Earth's condition. Based on the facts listed above, we propose a system to monitor the concentration of carbon dioxide inside a room in an office building. The system will give the carbon dioxide level readings from the sensors that are placed inside the building. The data that were gathered from this system will be used for further studies regarding efficient building designs and carbon dioxide levels. Literature review. In this section, we will discuss the literature that we have read in developing this system. This includes the development process of the system and also the algorithms that we used inside the system. The development process will follow the 5-stage systems development process by Nunemaker and Chef. The algorithm that we used in this system includes fuzzy. A 5-stage systems development process. In order to create a complete prototype of the system, we followed the 5-stage systems development process that was proposed by Nunemaker and Chef. The first process that will be done is idea brainstorming. This is conducted based on the problem and what solution that we could offer to tackle the problem. After we have brainstormed our idea, the next process is to identify and prepare the components that will be used in the prototype. After we have gathered the required components, it is recommended to do another session of brainstorming with the basic knowledge from the first session of brainstorm. The next process is to analyze and design the system. In this process, we will analyze and design the solution that is very possible to be done. Every possible solution will be reanalyzed so that it fits all the requirements that is proposed in the problem. The next step is to actually build the system and also perfecting the system. With the solution and the proposed system design, we will create the system according to the proposed design. The final step will be to analyze and evaluate the created system. This process will evaluate the system and create several adjustments if necessary. B. Fuzzy logic. The fuzzy logic was first proposed by Zadeh in 1965. The fuzzy logic is a technique that automates decision-making with fuzzy sets. In other words, the fuzzy is done to create a mapping network that is correct without the need for learning algorithms. Inference that is done on the fuzzy logic could be used on the data that is imprecise. A fuzzy controller is used to regulate the system based on the fuzzy rules. The measurement mechanism is done in the form of fuzzified, the inference is the computed, and the computation results are the defuzzified and converted into a certain value. Research method. A network model. The prototyping process was conducted using Arduino that has been equipped by a sensor that could measure carbon dioxide. The carbon dioxide sensor that will be used is a cozier ambient. The node cluster semantic sequence to read the concentration of carbon dioxide could be seen in Figure 2. The carbon dioxide concentration level that could be detected by the sensor is 0 to 10.000 parts per million. In addition, the sensor is also equipped with a built-in humidity sensor. The mechanism that is used to transmit the data is by using the Universal Synchronous Asynchronous Receiver Transmitter, USART. This sensor is connected to the microcontroller by using the RX and TX port. The picture of this sensor could be seen in Figure 3. Every node sensor will read a certain concentration of carbon dioxide, temperature, and humidity. The data will be sent to the sync node by using the radio frequency medium. After the data have been successfully gathered in the node sync, the data will be transferred to the serial Raspberry Pi by using the interface serial that is available inside the device. All of the data from the Raspberry Pi will then be transferred to the server node that is available in Amazon. The service that is used to transfer the data is Amazon Web Service, AWS. In the server node, the data is created in a tabular manner by using a simple RDMS in the form of PostgreSQL. From the data that have been gathered in the server node, the information of the carbon dioxide and the other components for every node could be retrieved from the website. The scheme of the carbon dioxide monitoring system can be seen in Figure 4. B-Sync node. The sync node is used to transfer the data to the server. The data transfer is used by using the Representational State Transfer Application Program Interface, RESTful API. One of the reasons why this data transfer method is chosen, the REST provides interface that is uniformed on every required components. By using the principle of software engineering, we will generalize and simplify so that the transferred data could be standardized into a certain format. The structure of the REST API can be seen in Figure 5. The data that is received by the Raspberry Pi using serial communication is obtained from the hop of the final node in the Arduino. After the data have been read from the Arduino through a serial communication, the available data will be parsed into JSON. After it has been parsed into JSON, we then post the data by using the request library that is available in the Python to the API endpoint. The REST API is constructed using Express, which is a micro-framework from Node.js. The diagram of the data transfer can be seen in Figure 6. C Software and Application. In this system, we used Real-Time Operating System, RTOS, that consists interface, commonly known as API. There are several benefits from using RTOS. Optimization of development program process. Synchronization that is safe and secure. Resource management. Timing management. The basic principle of RTOS is multitasking and concurrency. The main component of RTOS that is used to control and manage lots of resources known as the thread. The timing process of a task is called scheduling. On the other hand, context switching is the ability for the operating system to save all the state from a task that is being paused. In this study, the RTOS have been ported to the Arduino. Results. A experiment scenario. In this study, the experiment was conducted to simulate the usage of wireless sensor network, WSN, on several rooms to monitor and control the concentration of the carbon dioxide on each of those rooms. The rooms are simulated as a model that we have constructed using wood and then filled with gas of carbon dioxide using carbon dioxide tube. The experiment steps are: conduct the simulation process by filling the building room model with carbon dioxide. After there is enough flow of the carbon dioxide inside the room model, turn off the carbon dioxide gas. Turn on the sensor. The data will be sent to the server and the computation using fuzzy logic will be conducted by a computation unit. After we have obtained the result, the information to turn on the fan or not will be sent to the node that acts as an actuator. B. Results. The hardware and the components that are used in this study can be seen in Figure. Figure 7. Side view of the node that is inside the cluster. Figure 8. The front view of the model building that contains the fan and node. Figure 9. The whole building model that is used in this experiment. Figure 10. The carbon dioxide that supplies the gas inside the building model. Figure 11. The table that displays the results from that were read from the sensor. Figure 12. The graph that shows the intensity of carbon dioxide over time. See analysis. The performance of the algorithm, namely the fuzzy logic algorithm, is suitable and used for the current condition. The mathematical model in this study will be easier to create. However, the drawback of using this logic is that overfitting may occur at a certain point. The fuzzy logic also successfully controls the fan inside the building to turn on only when needed. 5. Conclusion. Wireless sensor network is a solution to monitor and gather data of the intensity of the carbon dioxide remotely. It is portable and it used a relatively low resource. In this study, we have successfully developed the sensor node to monitor and gather data of carbon dioxide concentration. The sensor node that we have developed used Arduino as a microcontroller, RTC as timer supply, carbon dioxide sensor to read the intensity of carbon dioxide, temperature, humidity, and also radio model in RF24L01 as a communication media for each node. The experiment have been conducted in order to test the implementation of fuzzy logic algorithm for detecting when the fans inside a building should be deployed. The experiment has been conducted successfully, as it is shown that the fan is only turned on when needed. 6. Recommendations. Some recommendations for future research are adding other air sensors such as methane or nitrogen oxide sensors as well as relays to control fans remotely. Thank you for watching my presentation. Goodbye.